Hi, today we're going to be talking about parallel line transversals, and this is Mr. Akatunde, your geometry teacher. When we talk about parallel lines, these are lines that are going in the same direction that will never intersect. You remember this from the 7th and the 8th grade? So today's lesson objectives will be to use informal arguments to establish facts about three things. One, the angle sum, which says supplementary angles and linear pairs add up to 180. The second will be to use our knowledge of vertical angles and exterior angles to establish relationships. The third one will be to draw conjectures about angles created when parallel lines are cut by transversals. What do we mean by transversals? You will see that in the video. This analogy on the screen will really help you understand what parallel lines are and what transversals are in layman terms. This is Gold Street, and it's running parallel to Silver Street. If there is another street that crosses the two of them diagonally, that will be called a transversal. Mind you, this could also cross perpendicularly, meaning going straight down at 90 degrees. But whatever line crosses the two parallel lines will create a transversal. At any transversal, we say that the angles created, the four angles created, are going to be congruent on the next parallel line. So we're looking at a street light here on 1, we're looking at a stop sign on 2, which is yellow, we're looking at a red stop sign on 3, and we're looking at a caution to a traffic light on 4. All those are also represented on 5, 6, 7, and 8. So these two parallel lines, alright, have the same symbols at the intersection. So today when we're going to be talking, you're going to hear me say that angle 2 is congruent to angle 3. They are both stop signs. So this will help you get it. The analogy is stop signs equals to stop signs. Those two are congruent angles. Alright, we're going to talk about traffic light equals to traffic light. Those two are congruent angles. But you don't want to say that a stop sign is going to be congruent to a traffic light. No. Let's get started. So let me connect with your prior knowledge. According to the linear pair theorem, which you learned in the 8th grade and in the 7th grade, you know about straight line angles. Angles on a straight line add up to how many degrees? Alright, answer that question for me. Alright, angles on a straight line add up to how many degrees? Alright, student, answer the question now. Angles on a straight line add up to, great job. I've seen some responses. Angles on a straight line add up to how many degrees? Alright, student number 2. Here you go, we're waiting on you. Student number 2. Angles on a straight line add up to how many degrees? Awesome job. Alright. Student number 2, great job everybody. So, I'll share the responses with you. Angles on a straight line, as you see, add up to 180 degrees. That's where we're going to start from. You learned that in the 7th grade. Now, as we proceed, you will see relationship between all these theorems, supplementary angles, linear pair. You will see relationship between them and parallel line transversals. So on a parallel line, angle 1 and 2 are linear pairs. They're on a straight line, so they add up to 180 degrees, like we just established. Look at this as well. If you turn your head, tilt your head sideways, angle 1 and 3 are also on a straight line. They are not congruent, they are not equal, but they both add up to 180 degrees. Great job. Angle 2 and 4 also add up to 180 degrees. A stop sign, a traffic light. They're on a straight line. They're linear pairs. They add up to 180 degrees. So also, angle 3 and 4 will add up to 180 degrees. Alright? Let's jump to Silver Street, which is similar to Gold Street. On Silver Street, what do you notice? Awesome. 6 add up to 180 degrees. Tilting your head, you're going to see 5 and 7 add up to 180 degrees. They're supplementary. They are not congruent. They are not equal. But they add up to 180 degrees. 6 and 8, 7 and 8 as well. Alright? The next vocabulary you're going to hear us talk about will be corresponding angles. What are corresponding angles? Corresponding angles exist when you have parallel lines cut by transversal. It says that an angle found on a spot on one line is going to be congruent to an angle found in a similar spot on the parallel line, on the other parallel line. So the first parallel line was a Gold Street, right? When we cross to the right side of a Gold Street, we see a yellow stop sign. Now I want you to jump to Silver Street, which is parallel to Gold Street. When you cross to the right side, you also see a yellow stop sign. So angle 2 is corresponding to angle 6. As you see on the screen, angle 1 is corresponding to angle 5. And then if you go below the Gold Street, you see a red stop sign, right? On the left side, right below the street, you see a red stop sign. It's number 3. It's angle 3. When you go to Silver Street, right below the Silver Street, on the left side, you also find a red stop sign. So angle 3, below the line, is corresponding to angle 7, below the line on Silver Street. So those two are corresponding angles. So what are corresponding angles? Angles found in similar positions on two parallel lines. Similar positions on two parallel lines. Now let's answer the other questions. Student number 1, student number 2, I need your responses. So let's look at this carefully. Alright, student number 1, what do you think? Which of these are not congruent corresponding angles? Of all three options, which angles? Look carefully. Alright, student number 1, student number 2, which angles do not correspond? Awesome job, students. Which angles do not correspond? Alright, student number 1, which angles do not correspond? Great job. Awesome. Alright, I'll share the responses with you. So according to the picture, we see corresponding angles on 1 and 5, on 2 and 6. Those are corresponding. Stop sign, 3 and 7, on 4 and 8. Awesome job. Alright, we're doing great. We're going to proceed to the next vocabulary word on parallel line transversals. We have dealt with corresponding angles, linear pairs, and we also talked about supplementary angles. Right now, you are seeing vertical angles in the shape of a letter X. If you open up a pair of scissors, the angle made on the top is congruent, is the same as the angle made at the bottom. The angle on the left is the same as the angle on the right. So one is vertical. Angles opposite each other are vertical. So in geometry, we see vertical angles are congruent. Angles that are opposite each other, across each other, are congruent. So when you're looking on the Gold Street, I see the traffic light, number 1, is congruent to the traffic light on number 4. The stop sign, although it's yellow on number 2, is congruent to the stop sign on number 3. Similarly, when you go to Silver Street, stop sign, red, angle 7, is across or opposite angle 6. They are congruent. They are vertical angles. Vertical, across. 8 and 5 are vertical. So it's more like a shape of a scissors, where you see the shape of the letter X in geometry. These are vertical angles. I need your responses, student number 1, student number 2, and let's get started. If these are vertical angles in the picture you're seeing, which of these conjectures will be correct? Is 5x plus 2x plus 24 equals to 180? Is 5x equals to 2 equals to 2x plus 24? What is the relationship between them? Awesome job, students. What's the relationship between them? Awesome job, student number 1, student number 2. Great job, everybody. So those two angles are across each other. They are vertical angles. Specifically, they are vertical angles and they are congruent. We're doing great. We're going to proceed to the next vocabulary word in transversals, parallel line transversals. The next vocabulary word will be alternate. The word alternate means hiding behind the transversal. All right, angles that are hiding behind the transversal. Take a flashback to your elementary. You played hide and seek. You stood behind the wall, hiding from your friend. You eat behind the chair, hiding from your friend. So this are playing hide and seek or playing tag with each other. So 4 hides from 5, 3 hides from 6. Those two angles are congruent. Let's jump to the Gold Street and Silver Street. This has been highlighted as an interior angle. So the 4 interior angles we have there are 3, 4, 5, and 6. When we're talking about alternate angles, they could be alternate interior, they could be alternate exterior. Let's look at alternate interior. So if you have two parallel lines, you can circle the sandwich on the inside. That's the interior. Think about this like peanut butter jelly sandwich. The bread is on top, all right, the other slice is below, the jelly is inside with the peanut butter. So this is the interior. On the interior we have angles 3, angle 4, angle 5, and angle 6. So look carefully before we answer the next question. Angle 3 is playing tag with angle 6. They are alternate, but they are on the inside. That's the difference. They could be alternate and be on the exterior. That will be 2 and 7, hiding behind the transversal line. 2 and 7. So those are alternate exterior. But alternate interior will be angle 3, hiding from angle 6. Will be angle 4, hiding from angle 5. Those are alternate interior. We could have alternate exterior. Angle 1, hiding from angle 8, behind the transversal on the outside. But anything hiding behind the transversal on the inside will be congruent, and they're called alternate interior. So think about angle 3, hiding behind the line from angle 6. They are both stop signs, they are congruent. Angle 4, hiding behind the line from angle 5. They are alternate interior. We have alternate exterior, like we mentioned. Look at angle 8, hiding from angle 1. These are alternate on the outside, Remember, the jelly is on the inside of the sandwich. So we have 3, 4, 5, 6 are interior. But now we're talking about alternate exterior. Exterior will be 2, hiding behind the transversal from 7. Those are alternate exterior on the outside. 1 on the outside is hiding from 8 on the outside. Those two angles are behind the transversal and they're congruent. 1 is a traffic light, 8 is a traffic light on the outside. They're congruent. 2 is a stop sign, 7 is a stop sign. They're outside and they're congruent behind the transversal. Alright. Student number 1, student number 2, and student number 3, I need you to put your responses in your own words. In your own words. We're going to have to type those responses. How do you explain alternate interior versus alternate exterior? Can you differentiate between alternate interior and alternate exterior? You have to type your responses, students. Try awesome attempts, everyone. On the inside, so that'll be 4 and 5. That'll be 3 and 6. Awesome job, everybody. Awesome job. Alternate interior is on the inside. All right, that's a good response. Alternate interior is on the inside. Angles 3 and 6 are alternate interior, while 2 and 7 are alternate exterior. Awesome try. Awesome attempts, everyone. All right, we do have a matching activity after the last one. So looking at this, angles are not congruent. Every other thing we've dealt with except supplementary linear pairs are all congruent. Same side consecutive angles are not congruent, they are supplementary. So when angles are hiding from each other behind the transversals, they are congruent. When angles are vertical, they're congruent. When angles are corresponding in similar positions on the next line, they're congruent. But when angles are facing each other, directly facing each other, they are not congruent, they are supplementary. That'll be 4 and 6, same side, consecutive, means following each other, same side. 3 and 5 are not congruent. A stop sign and a traffic light, they are not congruent, but they're facing each other. They are same side, on the same side, facing each other. This will add up to 180 degrees. That's on the interior. 4 and 6, interior, same side. 3 and 5, interior, or also called consecutive interior. Instead of same side interior, they can call them consecutive interior. We also have same side on the exterior. Remember, they're supplementary. Angle 3 plus angle 5 adds up to 180. Angle 4 and angle 6 adds up to 180. They are consecutive, same side. Same will happen when you get to the exterior. On the exterior, angle 2 and angle 8 are on the same side on the outside. If you skip over, on the same side on the outside, but they are not congruent. They are not congruent. On the same side, 1 and 7 on the same side on the outside exterior, but they are not congruent. They just add up to 180 degrees supplementary. This concludes our lesson. Let's take the exit ticket and let me check your understanding so far, students. Can you match the pairs? And let's see if you understand. How the pairs. So vertical angles are across each other. Alternate interior angles hiding from each other on the inside behind the transversal, versus alternate exterior hiding behind the transversal, but they are on the outside. Same side facing each other. They will never be congruent, they are only supplementary. And linear pairs are angles on a straight line